Hi everyone. So hopefully this should look pretty familiar. Here we have the slope, represented as m, is equal to the change in y divided by the change in x, which is also equal to the difference between two y's and the difference between their associated x's. So say I have a function f of x, and I want to find the slope, which I should probably mention here. The slope is equivalent to the secant line between 2 points. So I want to find the secant line, or the slope, between the point x and another point, which I'll call x plus some number delta x, or change in x. So using our equation here, we know that the equation for the slope is f of x plus delta x, or f of this number, minus f of x, which is y1, divided by x plus delta x minus x. Now, we know x plus delta x minus x simplifies to delta x. So the slope is equal to f of x plus delta x minus f of x divided by delta x. So let's try one more example. So say I have a function, I'm going to call it f of x, just to be original. I want to find the secant line, or the slope, between this point, x, and this point, x plus delta x. So the secant line, which is this line, or the slope, between these 2 points, let's call it g of x. So here we have our old equation, or we could use our old equation. We know that g of x is equal to f of x plus delta x minus f of x divided by delta x. However, what happens if delta x gets increasingly small, or very, very small? In other words, what happens to g of x as delta x approaches 0? Well, using this picture from Wikipedia, we can see. So here we have x, and we have x plus h. In this case, h is the same thing as delta x. So here we have our secant line, but now let's make h a lot smaller. So now we have a new secant line. Let's make h even smaller. Now we have a new secant line. Now let's make h so absurdly small that it's virtually 0. Now we have this new line. This is called the tangent line. So the tangent line, at any point, is equal to this rather familiar equation, as delta x approaches 0. So what you need to get from this lesson is that the secant line is equal to f of x plus delta x minus f of x divided by delta x, or the average rate of change, or the slope. Now the tangent line is equal to limit as delta x approaches 0 of the same equation, and the tangent line is also the same thing as the instantaneous rate of change, which might be familiar to you in physics. So although this wasn't explicitly covered in this video, you should remember that to solve tangent line problems, replace x in the function with x plus delta x. For example, if the function I have is f of x is equal to x squared plus 2x, and I wanted to find the tangent line at a specific point, then I would just replace x with x plus delta x. So this becomes x plus delta x squared plus 2x plus delta x minus x squared minus 2x divided by delta x. Then I would just cancel out terms, plug in, and solve. So thank you. Hope you have a great time in calculus.